It is 11:47 at night, and somewhere right now, maybe in a small town where the streetlights thin out at the edge of the road, a person is standing in a backyard with a cold cup of coffee going stale in one hand and their neck tilted so far back it almost hurts, staring up at something they cannot name. Can you feel that posture, that slight ache between the shoulder blades, that loosening of the jaw, that pressure behind the eyes where the day has been accumulating since 6 in the morning? And above them, above you, above all of us, the sky is doing something that has been doing it for billions of years without asking anyone's permission. It is showing us the past, not a metaphor for the past, not a symbol of it. The actual, literal, physically real past arriving at the speed of light into the pupils of every creature that has ever bothered to look up. So here's the question that Richard Feynman would want you to sit with right now, before we go a single sentence further. What if the past does not merely echo in photographs and memories and the footprints we leave in wet concrete, but what if it is actually structurally, cosmically present, coexisting with you right now at this exact moment as a physical object in the universe? Does that make the hair on the back of your neck do something? Good, because it should. Let's slow down for just a moment before we sprint, because the way Feynman always wanted to approach a big idea was not to rush into the equations, not to drown in the formulas before you have felt the thing in your bones. He used to say that if you cannot explain something to a curious person who has never studied physics, you probably do not understand it yourself yet. And he was right. He was frustratingly, brilliantly, annoyingly right about that. So let's feel this first. Think about the last time you went outside on a clear night, maybe not recently. Maybe you have to reach back a few months or even years. But somewhere in your memory, there is a night with almost no clouds and a sky that had too many stars to count comfortably. Do you have it? That faint tightness 3 fingers below the sternum that comes when something is too big for your chest to contain. That is the sensation we are going to spend time with today. Because inside that sensation lives one of the most radical ideas in all of physics. The idea that the past is not gone. The idea that it exists right now, simultaneously, in the same universe you're inhabiting. And that the light reaching your eyes from those stars is not a message from something that used to be there, but is in a very real sense the thing itself, still happening, still alive, still burning, arriving at you across an ocean of space that makes every ocean on Earth look like a puddle in a parking lot after rain. Bueno, and here's where Feynman would lean forward in his chair and get that look on his face, that half grin that said, wait until you hear this part. Because this is not just poetic language, this is physics. And the physics is so strange, so beautifully strange, that once you understand it, you will never be able to look at the night sky the same way again. If you're watching this for the first time and something in you is already feeling that pull, that sensation behind the eyes where a big idea is trying to settle, then you belong here. This channel exists precisely for people who feel uncomfortable with the idea that the universe might be stranger than they were taught in school. Hit subscribe. Join this crew of cosmic explorers, because where we are going tonight, you will want to remember the journey. And if you have a question, if right now something is already forming in the back of your mind, something like, but wait, does that mean leave it in the comments below? Some of the best thinking in physics started with someone refusing to let a half-formed question die. Now let's open the first real door here, and let me warn you before I can fully explain why the past still exists right now. You need to understand something about the nature of light itself, and before I can explain that, I need to tell you something about distance that most people have been carrying wrong their entire lives. And both of those threads are going to loop back around to something that might be the most unsettling, most magnificent, most quietly terrifying truth that physics has ever handed to a species that calls itself intelligent. So stay with me. All 3 loops are open, none of them close until we get to the end. Here's what people mean when they say the word distance in everyday life. They mean how far I have to walk, how much fuel I need, how many hours until I arrive. Distance is a practical measurement, a logistical inconvenience, something you calculate on a road trip. But Feynman understood, as Einstein had understood before him, as the great architects of modern physics had wrestled with across a century of hard thinking, that in the cosmos, distance is not just a measurement of distance is a measurement of time. These two things are not separate. They are stitched together into a single fabric that physicists call space-time. And once you truly feel that stitching, the universe will look different to you forever. Ispura, let's make this concrete, because Feynman always insisted on the concrete before the abstract. When you look at the sun, and please do not look directly at the sun, but when you look in the direction of the sun, the light entering your eyes left the sun approximately 8 minutes and 20 seconds ago, not metaphorically, not as a figure of speech. The photons that are landing on your retina right now, that are triggering the signals that your brain is interpreting as the sun, those photons were manufactured in a fusion reaction happening at the core of the sun, more than 8 minutes before you saw them, which means you have never, not once in your entire life, seen the sun as it is right now. You have only ever seen the sun as it was 8 minutes and 20 seconds ago. You have been watching a delayed broadcast and nobody told you. Now take that feeling, that slight vertigo, that tightness in the chest just below the collarbone, and understand that this applies to every single photon of light that has ever entered your eyes from any source beyond the end of your arm. You have never seen the present sky. You have only ever seen a layered, cascading, staggered exhibition of the past, arriving at different depths simultaneously. Pews, and here's where the numbers begin to do something to the human mind that no horror film has ever managed. The nearest star to our sun is called Proxima Centauri, and it sits roughly 4.2 light-years away. 4.2 light-years. What does that mean? It means that the light you see from Proxima Centauri tonight left that star 4 years and 2 months ago. If something catastrophic happened to Proxima Centauri yesterday, a catastrophic flare, a collapse, a silence where there used to be fire, you would not know for 4 years. You would spend 4 years pointing telescopes at a star that no longer exists, talking about it, naming things after it, and it would already be gone, but it gets worse. It gets so much worse that Feynman would have wanted you to pause here, to set down whatever you're holding, to let the next paragraph land in the empty space that the previous one just created. The Andromeda Galaxy, the largest neighboring galaxy to our own Milky Way, is 2.5 million light-years away. 2.5 million. The light you see from Andromeda on a very dark, very clear night, those faint photons that have been traveling through the void since before your species existed, since before the genus Homo had ever stood upright, since before the Ice Ages and the megafauna and the first stone tools, that light left Andromeda when your ancestors were not yet recognizably human. And yet when you look at Andromeda, what are you experiencing? You're not experiencing the past as a memory. You're not experiencing it as a record or a fossil. You're experiencing it as a live signal. The past is arriving at you. It is physically present. The photons are real. They are here. They are interacting with your biology right now. Unfinished sentence of Andromeda is being spoken into your eyes this very second. Here's where the loop deepens, because before I can explain what this really means about the nature of time and whether the past truly coexists with the present as a physical structure, I need to tell you about something called the block universe. And before I can explain the block universe, I need to tell you why Feynman had such a complicated, fascinated, almost obsessive relationship with the concept of time itself. Because Feynman was one of the physicists who understood, perhaps more viscerally than anyone, that the equations of physics are almost entirely time-symmetric. What does that mean? It means that if you write down the fundamental equations that govern how particles interact, how fields behave, how energy flows, and then you ask, would these equations still work if time ran backwards? The answer, with a very small number of exotic exceptions, is yes. The laws of physics do not care which direction time runs. The equations look the same whether you play the film forward or in reverse. So why does time seem to run in one direction for us? Why does a broken coffee cup never spontaneously reassemble itself from the shards? Why does the unscrambled egg stay scrambled? Why do we remember yesterday and not tomorrow? These questions haunted Feynman. They haunt every physicist who takes them seriously, and they lead directly to the most radical interpretation of what time actually is. The interpretation that physicists call eternalism, or more poetically, the block universe theory, and this theory says something that should make that pressure behind your eyes intensify considerably. It says that the past is not gone. It says that the future is not unwritten. It says that all of time, every moment that has ever occurred or will ever occur, exists simultaneously as a four-dimensional structure the way a sculpture exists in 3 dimensions. you're not moving through time. You're moving through the block, and every point you have passed through, every moment of your childhood, every Tuesday afternoon you barely remember, every conversation that changed you, those moments are not erased. They are coordinates. They are addresses in space-time. They still exist right now as physical locations in the structure of reality. Deham pensar un momento, because I want to make sure you feel the full weight of what that implies before we go further. Feynman once said something along the lines of this, that the most important thing is not to stop questioning that curiosity has its own reason for existing. And the curiosity that the block universe demands of us is this. If the past still exists as a coordinate in space-time, if those photons from Andromeda that are arriving at your eyes right now genuinely carry the physical imprint of a moment 2.5 million years old, then in what sense is that moment gone? In what sense is anything gone? The shadow of every civilization that ever rose and fell is still present in the structure of space-time. The footprints of every creature that ever walked on any planet are still there, encoded in the geometry of the universe, receding but not erasing. Does that comfort you, or does it terrify you? Because Feynman would say that both responses are correct, and neither is sufficient. Now let's come back to the second loop, the one about the nature of light, because this is where the physics gets genuinely strange in a way that earns the word strange. When Einstein published his special theory of relativity in 1905, he was working with a problem that had been nagging at physicists for decades. The problem was this. Maxwell's equations for electromagnetism predicted that light travels at a specific speed, approximately 299,792,458 meters per second. But this raised an uncomfortable question. Speed relative to what? If I throw a ball on a moving train, the ball's speed relative to the ground is the sum of the ball's speed and the train's speed. That is just ordinary physics. But light, it turned out, did not obey that rule. Light travels at the same speed regardless of whether the source is moving toward you or away from you. It is the same speed in every reference frame, and Einstein, young and brilliantly reckless, asked the question that everyone else had been too timid to ask: what if that is not a quirk of measurement? What if that is a fundamental feature of reality? And if that is true, what does it imply about space and time? Bueno, what it implies is the thing that Feynman loved to describe with barely contained delight. It implies that space and time are not absolute. They are not fixed backdrops against which events play out. They are flexible, relative perspectival. Two observers moving at different speeds will disagree about how long an event lasted. They will disagree about how far apart two things are. And most astonishingly, they will disagree about whether two events happen simultaneously. Simultaneity, the simple idea that two things happen at the same time, that idea breaks down entirely at relativistic speeds. What is simultaneous for one observer is sequential for another. The present moment, your present moment, this second, is not a universal fact. It is a local, personal, perspectival slice through the block. And someone moving at a different velocity would draw that slice at a different angle. Their now is not your now, and yet both slices are equally real cuts through the same four-dimensional structure. Does that make the tightness below the sternum sharpen? It should, because what this means, what Feynman wanted people to feel in their actual bodies and not just understand in their heads, is that the concept of now is far less stable than any of us were built to believe. Our brains evolved to navigate a world where the speed of light is effectively instantaneous for all practical purposes, where the relativistic effects of space-time are so vanishingly small at human speeds and human scales that we never bump into them. We were not built to feel space-time curvature. We were not built to experience time dilation. But the universe does not care what we were built to feel. The universe is what it is, and what it is turns out to be much stranger, much wilder, much more magnificent than the comfortable Newtonian clockwork our intuitions were shaped to inhabit. Pews, let's talk about what this means for the stars, because here is where the vertigo becomes something almost holy. When you look at the night sky, you're not looking at a flat, static display of points of light at some uniform distance from you. You're looking at a three-dimensional, or rather a four-dimensional time-staggered tapestry. Each star is not just at a different location in space, it is at a different depth in time. The light from a star 100 light-years away shows you that star as it was 100 years ago. The light from a star 1,000 light years away shows you that star as it was 1,000 years ago. The light from a star 10,000 light years away shows you a star that was burning 10,000 years ago, and you have absolutely no way of knowing whether it is still there. You're not looking at a sky. You're looking at a photograph of different eras developing simultaneously on the same film. And the developing agent is time, and the film is your eye, and the darkroom is the universe. Feynman had this quality that very few scientists have ever matched. He could make you feel that understanding something more deeply did not diminish it, but multiplied its wonder. He pushed back hard against the idea, popular in certain artistic and literary circles, that science strips the beauty from the world. He thought that was precisely backwards. He thought the person who understood that the stars were thermonuclear furnaces at incomprehensible distances, that the light from them was a time-traveling artifact, that the whole sky was a cascading archaeological dig. Through cosmic history, that person was experiencing more wonder, not less, than the person who saw only pretty dots. And Feynman was right. He was right with the particular ferocity of someone who had spent his life feeding his curiosity and watching it return from every expedition larger than when it left. Now here's where the third loop opens, and this one is the deepest one, the one that does not close easily. Because once you accept that the past genuinely coexists with the present as a physical structure in space-time, once you accept that the light arriving at your eyes from distant stars is not a message about the past, but is the past itself still traveling, still alive, still physically present in the universe, a question arises that Feynman would not let you escape. What does this mean for the intelligence that is trying to communicate across these distances? What does it mean for the silence we have been hearing from the cosmos? Because here's the thing about the block universe that nobody ever seems to want to talk about at dinner parties. If the past still exists, if every moment is a permanent coordinate in space-time, then every civilization that ever arose and burned out and went silent is still there, still burning, still thinking, still sending signals, or conspicuously, devastatingly, terrifyingly not sending them. Espera, because here's where Feynman's love of the cosmos collides head-on with the most haunting puzzle in all of modern science. The Fermi paradox, named for Enrico Fermi, who asked it with the casual devastation of someone who knew exactly what they were doing. The universe is approximately 13.8 billion years old. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. Estimates suggest that a significant fraction of those stars have planets. The chemistry of life, the basic organic molecules, the amino acids, the nucleotides, turns out to be remarkably common in interstellar space. We find them in meteorites, in nebulae scattered across the cosmos like seeds from a tree that nobody planted. The mathematics of probability applied generously but honestly suggests that if life can arise on Earth, it should have arisen elsewhere many, many, many times. Some of those life forms, given the age of the universe, should have had billions of years more than we have had to develop technology, to explore, to expand, to communicate. So where are they? Why is the sky silent? Why, in all the signals we have searched, in all the frequencies we have monitored, in all the decades of listening, have we heard nothing that unmistakably says, we are here? Feynman would sit with this question the way he sat with all questions, not with anxiety, but with the alert, almost predatory curiosity of someone who suspects the answer is going to be strange. And the answers that physicists and astrobiologists and cosmologists have proposed are indeed strange. They are a menu of possibilities, and every item on that menu is unsettling in its own particular way. One possibility is that we are genuinely alone, that the emergence of intelligent life is so improbable, requires such a specific and unrepeatable series of coincidences, that in a galaxy of 400 billion stars, it happened exactly once here, on this pale blue speck, orbiting an unremarkable star in an outer spiral arm, and that the silence is not a mystery, but simply the natural sound of a mostly empty universe doing what mostly empty universes do. That possibility, if true, is not comforting. It is the loneliest thing that physics has ever suggested. It means that the shadow of every civilization that never arose is cast across a past that exists in space-time as an absence so vast it has no name. But there's another possibility, and this one requires that tightness 3 fingers below the sternum to really dig in. Because this one is what some physicists and evolutionary biologists call the great filter. And the great filter is the idea that somewhere on the path from simple chemistry to interstellar civilization, there exists a transition so difficult, so catastrophically improbable, that almost no species ever crosses. A filter that stops civilizations before they can announce themselves. The question that should make the back of your neck cold, is whether the great filter is behind us or ahead of us. If it is behind us, if the extraordinary leap from non-life to life, or from simple cells to complex cells, or from individual organisms to cooperative societies, if any one of those transitions was so improbable that almost no other world has ever cleared it, then we are the lucky survivors. We are on the other side of the hardest part. The future, however difficult, is at least a future. But if the great filter is ahead of us, if there is something that every technological civilization eventually encounters and fails to survive, then the silence of the sky is not an absence, it is a warning. It is the universe's own way of whispering, look how quiet it is. Ask yourself why. Aver? And here's where Feynman's insistence on not hiding from uncomfortable truths becomes almost unbearably important. Because the evidence, such as it is, does not clearly favor one interpretation over another. Both the past filter and the future filter scenarios are consistent with what we observe. And yet the behavioral consequences of these two scenarios are radically different. If the filter is behind us, then the expansion of human knowledge, the investment in science, the cultivation of curiosity, the refusal to retreat into comfortable ignorance, those things matter enormously, but the urgency is perhaps slightly lower. If the filter is ahead of us, if civilizations regularly arise and then are annihilated by something they either did not see coming or chose not to look at, then every generation that turns away from science, every culture that celebrates ignorance, every institution that defunds curiosity might be nudging our species closer to whatever edge those other civilizations fell from in silence. Feynman cared about this with a depth that sometimes startled his colleagues. He was not just a physicist who found the universe interesting. He was a person who believed, with a kind of fierce and personal conviction, that the cultivation of honest curiosity was not merely an intellectual virtue, but a survival strategy. He had seen in his own lifetime what happens when societies decide that the answers matter more than the questions. He had worked on the Manhattan Project and watched what physics could be asked to do when curiosity was yoked to power without wisdom. He spent the rest of his career arguing, sometimes quietly and sometimes not quietly at all, that the most dangerous thing a civilization can do is stop asking real questions. Not because asking questions is comfortable, but because not asking them is the beginning of a particular kind of death that is much slower and much harder to see coming than the sudden kind. Dejam pensar un momento, because there is something else about the block universe that we have not quite addressed yet, something that brings the two halves of this conversation together in a way that might either comfort you or disturb you considerably, depending on where you're standing. We have talked about the fact that the light from distant stars represents the past, physically arriving in the present. We have talked about the block universe, the idea that all moments coexist as coordinates in a four-dimensional structure. We have talked about the Fermi paradox and the great filter. But there's a thread connecting all of these that Feynman would not have let pass without pulling on it hard. Here it is. If the past still exists in space-time, and if there were other civilizations that arose and fell, then their light, the photons emitted by their cities, their industries, their signals, is still traveling through the universe right now. It has not stopped. It has not been erased. The electromagnetic fingerprint of everything they ever built and everything they ever said is out there, receding at the speed of light, growing fainter, spreading thinner across the surface of an ever-expanding sphere. They may be gone, but their past is not gone. Their past is still physically present in the universe, encoded in photons that are right now, at this second, crossing the void. The question is only whether anyone is far enough away and has a telescope sensitive enough to still catch them. That is not a poetic metaphor, that is physics. That is the actual behavior of electromagnetic radiation in space-time. And it means that in a very real sense, if those civilizations existed, they are still speaking. We just might not have the ears for it yet. The universe is full of unfinished sentences, and almost none of them have reached their destination. Bueno, and now let's close the innermost loop first. The one about the nature of light, because there is one more piece of this that Feynman would insist we address, and it is the piece that brings everything from the quantum world into this conversation. Because the behavior of light is not just relativistic, it is also quantum mechanical. And in the quantum mechanical description of light, something even stranger happens to the concept of time and distance. When a photon is emitted by an atom in a star millions of light years away, it does not travel through space in the way a baseball travels through the air. It propagates as a probability wave, a wave of possible locations and times, and it remains in that indeterminate state until it interacts with something, until it is absorbed, until it is detected. And in the quantum mechanical sense, the photon does not experience the journey at all. For a photon traveling at the speed of light, relativistic time dilation is absolute. The time elapsed for the photon from emission to absorption is exactly zero. The photon emitted by a star 2.5 million light years away, and the photon that lands on your retina tonight, those are not separated by 2.5 million years from the photon's own perspective. They are the same event. The emission and the absorption are, from the reference frame of the photon, simultaneous. Feynman would grin at this point. He would probably tap the table with one finger and say something like, "You see, the universe is under no obligation to make sense to you." And then he would explain why that is the most wonderful news you have ever received. Because a universe that made sense to you immediately, that was intuitively graspable, that never surprised you, that would be a universe too small for a genuinely curious mind to live in. The fact that it is strange, the fact that photons from the ancient cosmos arrive without having experienced the journey, the fact that the past is still physically present in the structure of space-time, the fact that the sky above you is a simultaneous exhibition of different eras of cosmic history, that strangeness is not a problem to be solved. That strangeness is the universe being honest with you, maybe for the first time. Pews, now let's close the second loop, the one about time itself. Because this is where the personal implications of the block universe stop being abstract and start being genuinely, almost unbearably intimate. If the block universe is correct, if all moments coexist in the four-dimensional structure of space-time, then the moment of your birth is still there. The first afternoon you remember, with whatever specific sensory detail it carries, the smell or the light or the pressure of a hand, that afternoon is a coordinate. It is not gone. It is receding in the sense that you're moving through the block and it is behind you now, but it exists. The photons emitted by your body in those moments are still traveling outward through the cosmos, growing fainter and thinner across an expanding sphere, but they are real, they are physical, they are out there right now. You have left a wake in space-time that will not be erased for the lifetime of the universe. The unfinished sentence of your childhood is still being spoken, very quietly into the void. And this is what Feynman meant? Or rather, what Feynman would mean if he had said it this way, when he insisted that the value of scientific understanding is not just practical. It is personal, it is existential. Understanding the cosmos changes what it means to be alive in it. The tragedy that Feynman came back to again and again with a kind of frustrated, grieving insistence is the tragedy of the person who never looks up. Not the person who looks up and does not understand the physics. Not the person who looks up and feels overwhelmed. But the person who has stopped looking up entirely, who has decided that the sky is just weather and the stars are just decoration, who has traded the vertigo of cosmic wonder for the flat comfort of incuriosity. That person is not just missing something beautiful. That person is amputating a part of themselves that evolution spent hundreds of millions of years building. The capacity for wonder, the neurological machinery that fires when a mind encounters something genuinely irresolvably strange and responds not with fear but with hunger. That capacity is not a luxury. It is the thing that got us out of the trees. It is the thing that got us to the moon. It is the only thing that might get us past whatever filter is still ahead. Let's talk about what you actually do with this, because Feynman was always impatient with ideas that stopped at wonder and never arrived at action. He thought that understanding should change your behavior, change your perceptions, change the specific texture of your daily life. So what does understanding the block universe and the time depth of starlight actually change? First, it changes how you look at the sky. Every time you look at a star from now on, you will know that you're not seeing the star, You're receiving a piece of the star's past that is physically present in your present. The star is not there as a static object. It is a temporal artifact. You're looking at light that is older than your civilization, in some cases older than your species, in some cases older than the genus that eventually produced your species. And that light is real. It is here. It is interacting with you. The past is not a place you cannot visit. It is arriving at your doorstep at the speed of light every second of every night, and you have simply not had the vocabulary to recognize it for what it is. Second, it changes your relationship with time. Not in a mystical, vague, self-help way, in a physically precise, scientifically grounded way. If the block universe is correct, then your anxiety about the future and your grief about the past are both responses to a misunderstanding of what time is. The future is not blank and terrifying. It is a region of the block you have not yet moved through. The past is not lost and irretrievable. It is a region of the block you have already traversed. Neither is more real than the other. Both coexist in the same structure. Does that dissolve anxiety and grief entirely? No, of course not. The felt experience of time's passage is real, even if the structure of time is a block. But understanding the structure gives you something, a perspective from outside the flow, and perspective, as Feynman demonstrated relentlessly, is the beginning of every genuine insight. Third, and this one matters in a way that goes beyond the personal, understanding the time depth of the cosmos changes your sense of urgency about the project of science itself. If there are filters ahead of us, if civilizations regularly fail to survive whatever it is that comes for technological species, then the time between now and whatever comes next is not infinite. The silence of the sky is a data point. It is not a comfortable data point. It is the kind of data point that if you follow it honestly, wherever it leads, arrives at the conclusion that our continued existence as a species probably depends on our willingness to do the hard, uncomfortable, occasionally frightening work of understanding the universe we actually inhabit, rather than the universe we would prefer to inhabit. Feynman did not say that, but every piece of his thinking points toward it with the insistence of a compass needle pointing north. And here's where we need to talk about something Feynman cared about perhaps more than any single scientific result, the difference between knowing the name of something and understanding it. He told a story more than once about how his father used to teach him things by pointing out what was happening in the world, not by giving him the labels for it. His father would show him a bird and say in several different languages, "You can know the name of that bird in every language in the world, and when you're done, you will know absolutely nothing about the bird. You will only know what human beings call it in different places." That distinction between the label and the understanding between the word and the thing is the key to everything we have been talking about tonight. Most people know that the stars are far away. Most people have heard that light takes time to travel. Most people can recite the phrase light year without flinching. But knowing the label is not the same as feeling the reality. Feeling the reality means standing outside at 11:47 at night with a cold cup of coffee and a neck that aches and understanding. In your body, in the pressure behind your eyes and the tightness 3 fingers. Below the sternum, that the light landing on you right now from that particular star in that particular direction left its source before your great-great-grandparents were born. That you're being touched by the past, that the past is real, it is here, it is physical, and it is arriving. Dejam pensar un momento, because I want to make sure we have not left anything in the dark here, because there's one more implication of all this that Feynman would have pushed toward with that particular grin of his, the one that meant, here comes the part that should really bother you. And that implication is about the limits of observation. Everything we know about the universe, everything is based on information that has traveled to us at the speed of light or slower. We cannot observe anything that is currently happening beyond our light cone. We cannot receive any information about events that are simultaneous with us but located elsewhere, because that information has not reached us yet, which means that our entire model of the universe as we have mapped it, as we have described it, as we have understood it, is a model of the past. Not of a few years ago, not of a few centuries, of billions of years ago for the most distant objects we can observe. We are building a picture of reality out of temporal artifacts. We are archaeologists of the cosmos, and everything in our museum is already history. Does that make the picture wrong? No. But it makes it incomplete in a way that should keep every cosmologist awake at night, and that should make every person with a functioning sense of curiosity deeply, productively uncomfortable. There are regions of the universe that we will never observe because the universe is expanding faster than light can cross the distance between us and them, and the information about those regions will never arrive. There are events happening right now, at this moment, at the same cosmological time as your reading of this sentence that you will never know about. The universe is larger than its own observable shadow, and the observable shadow is already too large for the human mind to comfortably hold. Feynman would have found that glorious. He would have found it the best possible advertisement for the project of science. Look how much we do not know. Look how strange the knowing is. Look how the more we learn, the more magnificent the remaining ignorance comes. Ahora bien, let's close the outermost loop, the one that opened at the very beginning with that person standing in a backyard at 11:47 at night. Because everything we have traveled through together, the block universe and the time depth of starlight and the Fermi paradox and the great filter and the quantum nature of photons and the relativity of simultaneity, all of it converges on a single point. A single, quiet, almost unbearably significant point that Feynman spent his life trying to communicate to anyone who would listen. The universe is under no obligation to be comprehensible to you, and it is also under no obligation to protect you from the consequences of failing to comprehend it. These two facts held together without flinching, without retreating into either comfortable mysticism or comfortable denial, are the foundation of what it means to think scientifically, and thinking scientifically is not a career choice or an academic affiliation. It is a relationship with reality. It is the decision to look at the universe as it actually is, rather than as you would like it to be, and to find in that difference not despair but wonder, not anxiety but urgency, not loneliness but the extraordinary privilege of being, as far as we currently know, the only thing in this region of the cosmos that is capable of noticing how strange and beautiful and terrifying all of this is. The past still exists right now, simultaneously with you. The light from Andromeda that is reaching your eyes on a clear dark night is not a symbol of the past or a reminder of it. It is the past, physically present, arriving. Every photon from every distant star is a temporal artifact, a piece of the block universe traveling to meet you. The footprints of everything that has ever burned or lived or communicated in the cosmos are still out there, receding but not erased, encoded in the electromagnetic fabric of a universe that keeps every receipt. And you, standing in that backyard with your cold coffee and your aching neck, are not a passive spectator of this spectacle. You're part of the block. Your own photons are already traveling outward, have been since the day you were born, carrying the unfinished sentence of your existence into a cosmos that might billions of years from now be intercepted by something with the curiosity to wonder who sent them. Feynman wanted people to feel what it means to live inside this, not to memorize it, not to recite it, to feel it in the pressure behind the eyes and the loosening of the jaw and the slight ache between the shoulder blades that comes from tilting your head back far enough to take in the whole sky. He wanted you to understand that science is not the enemy of awe. It is the amplifier of it, that the more you know about the universe, the more surfaces there are for wonder to land on, that the person who looks up and sees only pretty dots is not experiencing the sky. They are experiencing a thin, impoverished, two-dimensional projection of something so vast and so strange and so magnificent that it requires a whole lifetime of curiosity to even begin to approach it honestly. So look up, not because it is relaxing, not because it is pretty, but because the sky is a time machine, and it is running right now, and it is free, and the only ticket required is the willingness to ask what you're actually seeing. The past is not behind you. It is above you. It is arriving. And if you pay attention, if you refuse the comfortable amnesia of incuriosity, if you keep asking the questions that make people at dinner parties shift in their seats, then the unfinished sentences of the cosmos will keep finding you night after night, carrying their billions of years of travel right to the surface of your eyes. And that, as Feynman knew with the whole of his magnificent, restless, irreverent mind, is not a small thing. That is the whole thing. That is everything.